square of Clausen integral function. So I'm back with this nice integral, and the integral is of the square of the Clausen integral function. Yeah, we all know the Clausen integral function. Yes, the Clausen integral function is defined as the sum from n equals to 1 to infinity of sine of nx by x square. Yeah. And yeah, so if we just needed this definition to solve this integral actually, and this is pretty easy to be honest than the other ones that we do in the channel. And let's start. So this is this integral from 0 to 2 pi, and then sum from n equals to 1 to infinity sine nx by n square. Yes, and then sum from k equals to 1 to infinity sine kx by k square. Yeah, and dx. Okay, now these are the definition. Now we will try to interchange the sum in the integral. So we have sum from n equals to 1 to infinity, sum from k equals to 1 to infinity, and then integral from 0 to 2 pi. Yes, and this n square and k square are just the constants for the integral. So let me write it over here, n square k square. This doesn't look good, so let me make it proper. Yeah, 1 by n square k square, and then integral from 0 to 2 pi sine nx sine kx dx. Yes, now this integral is also pretty interesting integral, and you might have also seen this while learning the Fourier series as well. Now let me show why this is interesting. So this integral 0 to 2 pi sine nx sine kx, this integral actually evaluates to two different values for two different cases. Yeah, whenever n and k are different, in that case this integral will just be 0 if n is not equal to k, and this will just be pi if n is equal to k. Let me show you why. Now to evaluate this integral, what you can do is you can actually write this as a sum 1 by 2 integral from 0 to 2 pi, and then this will be cos of nx minus kx, yes, minus cos of nx plus kx and dx. Yes, and after that we can integrate it. So 1 by 2 sine of n minus kx by n minus k, and minus sine of n plus k x by n plus k. Yes, and this all goes from 0 to 2 pi. Okay, so now if n and k are different, we can clearly see that at 2 pi and 0, at both the values, like both the terms are going to 0, and so obviously it will just be half of 0 minus 0 minus 0 plus 0, and that will just be 0. Yes, if n and k are different. But if n and k are same, or in the case where n and k are same, we can see that this n minus k will be 0 in that case, and then sine 0 by 0 form, we can just write x over here, again write x over here, this will just go to 1, and we will just have x over here if we take the limit. So you can see that when n equals to k, we actually have the following expression: 1 by 2 over here x minus over here sine 2nx by 2n, and this all goes from 0 to 2 pi. Yes, and then we have 1 by 2, this is 2 pi, and sine of some 2n times 2 pi is just 0. At 0, this is minus 0 and plus 0. Yes, so this actually evaluates to pi. We can clearly see that. So over here we notice that when n and k are same, this evaluates to pi. When they are different, this evaluates to 0. Okay, so over here also, whenever in the sum n and k are different, this term over here that's evaluated, this term will just go to 0 because this expression over here will be 0. Yes, so we only need to consider the cases where both are same. Yes, so let's just take a sum in which both are equal. Yes, and they go from 1 to infinity, And yes, so there is just we can just take only one sum, because we can take the first sum and second sum we can just consider only one value. So yeah, one sum is fine. Now this is just n square and also n square, and this integral will just be pi. Yes, so pi times sum from n equals to 1 to infinity of 1 by n to the power 4. Yes, and we know that sum of 1 by n to the power 4 is just pi to the power 4 by 90. Yes, and that's why the answer is pi to the power 5 by 90, and that is a pretty good answer. Okay, so we have solved this problem, and yeah, we have got the same answer. The flow was just to use the definition and then deal with this interesting sum, and yeah, make the guesses, get the answer, and that is it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.